Hello teacher, we are group 1 and today we are going to talk about the project in our programming studio course, and we are developing a web application to address a social challenge that has been provided in this course. The project purpose focus mainly on the topic about climate change, and our web application will have the normal people as well as the professionals to analyze the fluctuation in the temperature as well as the populations. And furthermore, it also have some professionals such as the government member or the scientists to make some policy which will help to create a sustainable environment in the world. Regarding the requirement of the project, we will answer the key questions, which is how does your website achieve the goal of addressing the social challenge? To answer the questions, we will follow the structure below.
Now we go to the part that shows how our website meets the requirement of the level 1, 2, and 3. Firstly, we go to level 1. Level 1 big picture content mainly focusing on the capturing user attention and providing an overview of the website. Our landing page can solve all the requirement of the level 1, which is attractive in helpful design. As you can see, we have the navigation bar on the top of the web that provide the news, data, and some contacting detail. On the left side, we have the map and some key data like population, temperature range, and the scroll bar that can help users know that they can get the data from the 1750 to 2013. Yes. And on the right side, we have the general information about the website and the start now button to start the function. And we have the description that can help users know how to use our website effectively and get the suitable data for their needs and goals. And the perspective provide our mission to everyone. In addition, we have some persona that represent our target users and their needs and goals. Finally, we have the member section to provide all of the member details. After clicking on the Start button at the landing page, the user needs to choose one of 3 view modes: the global and country, the city or state, and the display data for level 3 requirements. After choosing one of them, the user needs to input some information like the kind of temperatures, the average, the maximum, the minimum, the start year, end year, and the name for a country if they choose the country view mode, as well as the land or both land and ocean for the global view mode, and also the sorted or the by population or temperature. When they finish their filtering, they can get the graph that show the data about the temperature and population change over the period they choose. Besides that, if the user choose the city or state view mode, they can also get the ranking for the city or state by temperature change over the period. At the level 3, the user firstly need to choose the property they want to sort, the country, the city, or the state. After choose one of them, the user need to input the starting years, the time period, and the name of city, state, or about the country they want to sort and compare with. When they finish the filter, there will be a list provide information about the ascending or descending order by sorted on regions in the different average. And also a graph can be updated dynamically by linking the option of temperature in average or different in average in the time period they choose. About the setup B, the user can also input their properties like the population, the temperature, or both of them, and the starting year and the time period, and about the similarity values, and also the property they want to sort. Furthermore, we have the top-ranked result that user can choose the number of the similarity region they want to see. When they finish their filter, there will be a prominent graph display the chosen data for the selected regions, and a separated graph and a ranked list showcase the similarity scores and corresponding data for the top-ranked regions. That's all of our website that meet the requirement of 3 levels.
Our UX UI certify the relevant context scenario tied to the relevant persona. Here are 3 personas that we have mentioned in the milestone 1, and we have summarized the general need and goal from our persona and translate to the 3 context scenario, and I have put it in the file that I will submit to you, so hope you can view it. So let's talk about how our UX UI satisfy the context scenario. So in the level 1, you can see that the landing page, there is the place, we circle it with the red color. This will provide a general overview of population and temperature from 750 to 2030. And the 2 page, this will help user to know more about our website, about the purpose as well as how to use our website. And before viewing the data, user need to choose the level which is suitable for them. So our target persona had 2 levels, non-professional and professional. The first 2 levels is suitable for the non-professional, and the last one is more suitable for the professional. So this is the UX UI in the level 2. You can see that they have the input field on the top, and the data will be shown in the center with the graph, and the ranking sorting table will help user to compare the data. And this is the level 3. Although there are some different in the design, I think that they still remain the main function of them, which is the input field about the condition of user on the top, and the main data will be in the center. And next I will talk about the Nielsen heuristic we have followed, and we have make use some UX UI pattern. So the first page, the landing page, we have make use of the escape hatch and navigation tab, and we also follow the first heuristic, visibility of system status. We have used the concise terminology related to the climate topic. And the team member page, this make use of the grid of equals pattern, which will have user focus view on all member with some important information about the people who created website. And here the page that show data. I have mentioned before the input prompt in the top, and the data will be shown in the center. You can see that we also make you annotate scroll bar, and we have followed the 5th heuristic, error prevention. So the button will be, by default it will be done, but when user click it, it will change to new query. We make it because we want to ensure that when user click done, the field in the input prompt will be locked and they cannot change while they are view the data, which can make some error if there are some change in this input. and we have used the same structure, the same design to show the data in different level, which will help user to be familiar with our website. This helps us to follow the fourth heuristic: consistency and standard. User will not have to learn again how to use our website. And we have also followed the first one, visibilities of system status. So when user click one element on the sorting table, they can see the data which is match with the element they choose. And that's all.
Okay, so now we will continue with our AR diagram and database design. So we will start with our AR diagram. You can see we have both weak and strong entity. So we also identify really clear variable keys like the name, the years, the locations that help us to clearly separate between the tuple within an entity. And this is the teams and the persona diagram that we also use to show the data for our landing page of our web applications. We also list on the entity and the relation into the form of the relational schema here. In the schema, not only the variable keys and the attribute, we also show the foreign keys of all entities, which is not shown on the ER diagram. We also propose an 3NF ER diagram. The key difference between our ER diagram implemented in our database and this 3NF ER diagram is that it have the region entities, which have the attribute including region ID, region name, and region type. We add these entities because we consider that with the entities we can show the relationship between the regions and the year and the temperature more clearly. However, in practical scenario, we consider we have to join at least 3 tables for a query if we want to take the data of the temperature of the populations. So this will make a really low efficiency when we make the query to get the data. So in real life, not only follow the principle and the theory of database design, I think sometimes we have to sacrifice to make our web app performance as good as possible. And we also list down the dependencies, functional dependency of the above ER diagram. Yeah, we have on the relation here and the attribute which depends on the other attribute. So next we will move on to our SQL code. We have some kind of DL code here. We store on the initialization code for on a table of our database. So in this case we have some problem, we can recreate the table and add the data later. Especially we also create some kind of index for some attribute about the table, so it will make the query much faster than without the index inside them. We also combine the SQL code and the Java. So this is the Java file that we use to get the data from the CSV file to our database. We have many functions here. Add population data, add country temperature data. The same purpose is to add the data from the CSV to our database. And next we have the user controller, which also combine Java and the SQL code that we use to process our data visualizations, the chart, the graph on our web applications. Yes, and this is the end of the data and AI diagram of our web application, so we will move to the next section.
Regarding the usability testing, our group have gathered notes from the observer as well as the feedbacks from the post-survey questions. Color is one of the two main issues that we identify. Participants found out that the interface color is confusing, impacting the experience, and the original palette lacked clarity, making it difficult for users to navigate effectively. Here is the before image of our group wireframe. As you can see here, the overall visualization of the page is not really clear, as well as the button navigations. One of the participants find it difficult to navigate the starting point as well as seeing the text. Here's our landing page wireframe after image. The transformation of the Start Now button from a dual blue to a liquid green as well as the softer color tone has helped enhancing user focus. Persona before and after image. Level selection before and after image. View mode before and after image. The second issue that our group has identified is the navigation buttons. Throughout the testing, a lot of participants were stuck. They couldn't go back easily after choosing a level or find their way to the home page quickly. Here is one of the 3 levels that our group forgot to display the return button. In order to fix the problem, we added a clear back as well as the home button on the navbar, so there will be a way to go back and start over again without any hassles as we move on to the level sections. With the provided changes, our platform not only meets user functional needs but also offers an intuitive and stress-free navigation experience, making the journey through our website easier and seamless, as well as informative throughout the 3 level sessions.
Hi everyone, so today we will do more our website. So first we will talk about our tech stack. To create for frontend, we use our HTML, CSS, and also JavaScript. And for the backend development, we use our Java and also the library Javelin. Also, another thing that we use library for frontend, that is Chart.js to create chart for our website. So first we will go through landing page. So this is our landing page. Yeah, normal. Yeah, this is how to use our website. And also this one is about our personal information. And this is our team member. Okay, we will go through this quickly. So for our data navigation, when you click in it, it will show you choose your level. Yeah. So for a beginner, you will click level 1, for medium, level 2, and for expert, you can do level 3 in our website. So first, we will go in level 1. So in here, we can see that we can choose view by word or country to show data and select start year and end year. And then when you click next, it will go through oh, there's some error. We go to next page. So in here, that is you can see it's a view by word, and we have many kind of temperature in this average, min, max, and you can start starting year. For example, I will use this. Okay, when click done, it will show a list, and it can auto ranking by raw value or proportional value based on user choice. In here, so temperature in a blue
and in the pinky is a population. Yeah, you can switch it, like switch data, proportional value, nothing too special. Also, it's very dynamic. For example, let me see. Yeah. Okay, go back. So when we go back into our choose level page, when we click level 2, it will show the list of form you need to place. So in here, I choose right. I like American, of course. So I will choose maybe United States in here, and click next. So in here, it will show the United States country, and in here you view by city. It's automatic. Put a city in here, right? So for example, I want to choose a starting year from this to this. This will automatically show a graph. It's a line graph. Yeah, it's ranking in here. It's ranking by raw value, and when I click in here, it will change the data. So when we click, actually underline, it will go through my server that we create with Javelin, and it will feedback. When we get something, it will give our data. For example, if I want to select in here, I want to select a temperature of all country in a certain starting year to the end year. It will actually give back to our information that through JSON. Yeah, maybe you want United States, right? Yeah, if we give your information about United States, and when we send it back, we will use JavaScript to manipulate data. So by proportion, yeah, it will change, and you can actually hover it to show the data about its temperature, a C degree. Yeah. In level 3, we will have this is our website. In level 3, it's kind of complicated. First, in here, this is starting year, and then the time period, and then you choose a current region that you want to focus on, and you can choose to view by absolute value or relative value. And this is a ranking. In here, it's a ranking top 5, but yeah, maybe user choose 10 but not click done, so it's only so top 5. So about temperature, in here you can show average, min, and max. So in here, to calculate a similarity score is based on this equation that we put in this website. And also on the left side part, you will see this is based on the current country that we click in here, Austria. So the similarity score will describe the similarity of data between data. Okay.